Okay, so yes, I am. So write down.
Hello.
You are so mature. I appreciate it.
Okay, wait. I thought that they were all categories. Can I ask you
Let's go. Okay, so let's take a look at what we had done with our previous chapter 3. We know that with categorical, we previously had done bar charts and pie charts. Also our contingency tables, that's our marginal distribution and all that kind of stuff. So bar charts and pie charts, were used for our categorical data. These types displays, however, are not appropriate for quantitative, and that's what we're going to learn today, is which types of charts would you use for quantitative data. And those types would be this: a histogram, a dot plot, or a stem and leaf plot. And so that's the 3 that we're going to talk about today and talk about the benefits of them. Okay? Now, histogram looks like your bar chart, but what's different about a histogram? Yeah, good. In a histogram, the interval corresponding to the width of each bar is called the bin. Bin is the width of each bar, B-I-N. And a histogram displays the bin counts as the heights of the bars. Just like bar chart, you count how high you're going. Unlike a bar chart, the bars touch one another. Okay? It makes sense to put them in a particular order. For example, if I had a histogram of lawyer fees, which that's an example that I gave back in the last notes, suppose, this is my $100 to $200 account, and my 201 to 299, whatever. Okay, well maybe I have an empty space in between my bars and I have a gap, and so these are all going up by 100s. These are all bins of 100s amounts, but I got a gap here, and then we get into the 7 to 800 per hour and so on, and so my bins. So why do you think that we could have this gap here, and why do you think in real life we could have this bimodal distribution where I have 2 kind of categories of data? Why do you think that could happen if lawyer fees? No. Like, if these are $100 to $200 type fees, that's normal people, right? These are money. Who could this be? Like celebrity lawyers, corporate lawyers, good. Okay, so you could have a break. You might not have a break. I mean, it might be continual, but I'm just describing why you might have a bimodal type of situation, which we'll talk about later. But see, I have 2 kind of sections of material, and you might have a gap right here in the middle, and you might not. Okay. Yeah, it does. Okay, let's do our shoe sizes real quick. Okay, this is fun. Now, it wouldn't make sense for us to put size 6 and 7, or all the size 6s in one, all the size 7 in one, all the size 8s in one. See how they split it up with half sizes? The reason is because a histogram is helpful if it has about 10 bars. Now, we also could do relative frequency, but we don't have time to calculate that percentage now. We could do relative frequencies. Our histograms are helpful and useful when working with large data sets. The 29 people that we have in this class I wouldn't quite call large, but I can chart all you 29 people pretty quickly. They can easily be constructed using a graphing calculator, and we'll get into that next chapter, chapter 5. I'm going to make sure that you've got some calculator skills next chapter. But a disadvantage to this histogram is that they do not show individual values. For instance, raise your hand if you wear size 6 shoes. Okay? Raise your hand if you wear a size 6.5, and you can do this down as we go, or just not. Size 7. Okay, guys and girls. Size 8 or 7.5. 7.5. 1, 2, 3, 4. Okay. Size 8. 1, 2. Okay. Size 8.5. Okay. Size 9. Okay. Size 9.5. Okay. See how we had a gap there, though, at size 7? Nobody had size 7 shoes. Size 10. Okay. So what's happening now? Who's starting to kind of show up in here now? 10.5. What size are you? Okay, 11. Okay. Oh, did I mess up on that one? No, did anybody have 10.5? I think I got off. 11? Okay, 11.5. Okay, and 12. 12.5. 13. Okay. See, so I got a collection of all that data pretty quickly. It's kind of, you could classify this. I might say it's bimodal because I reached this twice. This is pretty kind of scattered, and it's difficult because I level off right there. But I could say that. Why do you think this bimodal situation happens? It worked out really well in this class, actually. Down here, what did we have mostly? Girls. And over here, we had mostly the guys. Okay, and there's some overlapping here, especially when we get into this section. But there you go. Okay, so I would have probably described this as bimodal because I have two kind of humps there where I have two heights kind of representing two different classifications. Okay. Stem and leaf plot. Oh, I wanted to point out, sorry, before we go on, I wanted to point out the downfall to a histogram is I can't get the individual data. Like I can't find out who is the person that was in that 12.5 category. Whereas if I had done it in a different way, I could have. Stem and leaf charts, leaf plots, are similar to a histogram. In fact, if you turned a stem and leaf plot on its side, it actually would look like a histogram. They show individual values rather than bars. It may be necessary to split them into a range of values if they're small. Look here, this is the number of shoes that you have. So let's see if we can't fill this in real quick. I have a grid on mine because I want to make each number I put in there equal area, kind of to obey the area principle. And then when I turn it sideways, it's going to look like a histogram. But let's show you how we would do this. Why might I have zeros listed twice and ones listed twice and so on? Why would that have been broken up that way, and what did that represent? What? No, not girls and guys. Actually, this 0 is going to represent 0 to 4, and this 0 is going to represent 5 to 9. This 1 would represent 10 to 14. And this one would represent 15 to 19. Okay? And so let's now calculate. This is just kind of giving you an idea of what these numbers represent. So this is called your stem. And then you draw a line right here next to your stem. And then these numbers here that we're going to put in here based on the data we collect are called your leaves. So that's why it's a stem and a leaf plot. So raise your hand if you own between 0 and 4 pairs of shoes. Okay? And so then tell me how many. Okay? Okay? 3? 3? Okay? All right, so I got 1.5, which I'm just going to put as 1, sorry. And then I had 3 threes. So this tells me, hey, you guys listen up. This tells me how many people I had in this section and specifically what those counts were. Okay, how many people had 5 to 9? 5. Okay, so I have 5, 5, 5, 5, 6, 7. Anybody else that I missed? Yes? Oh, she said 6 and I, okay. All right, so we've got more in that category. If I turn this on its side, can you imagine that bar would look taller? It had more counts. Okay, how about in the 10 to 14 range? Okay, right here. 14, 11. Okay, 14, 11, 13, yeah, 12. Okay, so 11, 12, 14. Did somebody say 13? Okay, well that's easy. Okay, now look at how this works. This is 11. 1, 1 is 11. 1, 2 represents 12. 1, 3 represents 13. And 1, 4 represents 14. See how that works? Okay, what about 15 to 19? Okay, how many? Okay, so 15, I don't know, I'm just making 16, 16, 16, 17. Okay, so there we go. So that's 15, another 15, another 15, a 16, a 16, a 16, and a 17. Okay, now I'm just going to pretend like we all filled in the rest of the data. I know one person in my other class had 73. Okay, yeah. Okay, so that makes me sad. I'm thinking about all the people who don't have diapers or formula, and we've got 73 pairs of shoes, okay? So, but look here. I want you to turn your head sideways and think of this as a histogram. Here's our mode. Look at this, and then goes way stretched out here into the 70s. So turn sideways and think of this as a histogram. Here are the bars. See, that goes 4 high, and that goes 6 high and 4 high. Okay, and that one goes 7 high. Okay, but look at this one down here. That one's 1 high. So this would be considered a what? Outlier. Very good. Furthermore, I would describe this shape as having a tail. If I'm looking sideways like this, it's tail what? Tail on the what side? Right. Tail right. So you would say that this is skewed right. So the benefit to this stem and leaf plot is not only can I get the individual counts inside there, but I have all the benefits of it looking like a histogram when I turn my head sideways. I don't know if I can do this, grab this data. Oh, see, that's the wrong one. Yay, kind of. Okay, but anyway, we're going to all mess it up. But anyway, I can't grab it. All right, you can compare back-to-back leaf plots if we wanted to compare guys to girls. Let's say we had the guys, remember they had like 3, 3, 3, and 1. And then for the guys, we had like 5, 5, 5. But then we had a 6 and a 7 here. But then we started getting all of the 11, 12, 12. I think we had a 13. I think we had some 13s and some 14s. But you see how I can get lists on both sides, and it's possible that we would see the female distribution look differently than the males. Okay, the female, so I know, it's not a very good, I'm sorry, I'm just kind of sketching it really quickly. But you can do a back-to-back stem and leaf plot when you are comparing two distributions. Stem and leaf, they correspond to the bends, just like in a histogram. So remember how we talked about turning it sideways? You may only use one digit for the leaves. You can only use one digit for the leaves. That's key. So if I was going to do something like, we're going to do SAT scores here in just a second just to show you one. But you could do small to moderate, whereas with a histogram you can use bunches of data. It's pretty tedious for a stem and leaf, so you want to use small to moderate. The benefit is that I could see those individual values, couldn't I? I could see 13, 13, 13, 14, and 15, and all those individual values. Let's do SAT scores. SAT scores, let's just do the upper part of the SAT scores. Say we got like, because they're usually like in, how's the SAT score come? 1810, 1820, 1830, okay? 2130, okay? Okay, so you guys, I'm expecting to have really high scores here. Watch this, how I would show this SAT score. Who had an 18-something? Or anybody? I don't know, you don't have to tell me. That's response bias, okay? I'm like putting you on the spot. So let's say our thing was 1810. Instead of putting a 10 here, I'm going to put 181 because they all end in 0. So just knock off that 0. I don't need it. What would this represent? 1820. What would that number 4 represent? 1840. Okay, what's that right there? 2020. 2250. Okay, so on. So you want to have just one digit over here in your leaves, so you may have to mess around with how you decide to do your data and cut off some things so you just have one. Okay, real quickly, dot plot, guess my age. Oh man, we're about out of time, aren't we? Okay, you have to, let me tell you, real quickly, you have to do this with center. You get to cuss in here. You have to do this with center, unusual features. Oh, sorry, this is supposed to be unusual, okay, because I can't write when I'm under pressure here. Unusual features, like if we have outliers, features, okay, and then shape. So shape would be like unimodal, bimodal, uniform would be flat, and spread. We're going to talk more about spread next chapter. Let's label these really quickly. What would you call this one? Bimodal. The next one would be, I'd say uniform. What about this one here? Unimodal, because it's just got one height. Okay, what about this one? Where's the tail on it? Left, so therefore this would be skewed left. Tail left, skewed left. This one, where's the tail on it? To the right, so you say skew right. Okay, wherever the tail is, that's where it's skewed. So the way you have to do this is center, unusual, I usually say center, shape, spread, and unusual features, but there you go. And I think that might be it. We did get to do our rent-a-date activity, where you would get to look at your notes on the back and you'd have $22. Your notes are really long. I think that they might have been because it has all the answers in it. So we did get through everything. So you do have your homework that you're going to do. But look at our rent-a-date. What would you pick if you had $22? Now I'd have to define a date. This is a evening with a potential lifelong partner, okay? So that's a date with a potential lifelong partner. You have $22 to spend. So let's just talk. Look at your rent-a-date. What type of chart or display do you think we would make with all of those? I was going to give you Post-it notes after you figured out what all your qualities were, and then you'd come and put them up here. What type of thing would I make? A bar chart? Would it make sense to be a histogram where they're connected values? Or would they all be separated? Because what type of data is it? Categorical data. So I would not do a histogram. I would have done a bar chart. They would have been all separated. Okay. Yes.